Fingers crossed. Okay. Leon.
Well, thank you all for
I'm
being
going to
here.
just hold on for a second because I've got to mute everybody. This is very important to mute everybody, otherwise, and then you'll have to unmute yourself. There we are. There you go.
So thank you all for being here. It's lovely to see many laws of form people. Hello, Graham. Oh, what did I do? I destroyed my wonderful PowerPoint presentation. Hold on. Ah, there we are. Pressing the wrong button. So, yes, Graham, Aylesbury, hello. So, great laws of form people here. And hello, everyone else. Today, I'm going to talk to you about the qualitative aspect of classical logic and its relation to George Spencer Brown's laws of form. I know not everyone here appreciates laws of form, but I hope to win some of you over and share some of my love of it with those of you who are already familiar with the work. This talk is going to be about logic, but it's also largely going to be talking about puddings, and specifically Norman Lindsay's magic pudding, a pudding with a personality. This pudding had the magical quality of being able to change its flavor or substance according to its eater's will, and it had a consistently grumpy mood. However much of it was eaten, its substance remained unchanged. It despised any abuse of power and was a stickler for correctness and justice. It has much in common with logic, I think, which Mortimer Adler described, along with its trivium partners, grammar and rhetoric, as an intellectual or liberal art and a formal science, concerned with the forms of any subject matter. Bearing that in mind, one would think that laws of form would be specifically and particularly suitable to it. In Laws of Form, Spencer Brown talks about a triplicity of a recipe being a set of injunctions you use to recreate something ineffable, the taste of a pudding. Through its physical form, you get to its metaphysical substance. It's the same with music, a musical performance, and a musical score, or mathematical demonstration, mathematical practice, and mathematical proof. And there's a similar triplicity which can be found in logic, an instrument of the intellect acting in and on itself through the means of reason. So in logic, the pudding, the taste, and the recipe are all one and the same. The link here to the trivium going up to the quadrivial subjects and to gastronomy in the place of philosophy or henosis is worth contemplating. And my question is this: if logic were to come to life and comment on how it's been treated through the ages, as the magic pudding is able to do, what might it say? If it were defending itself in a court of law against abuse, who might it draw on for its defense? Who might it accuse? I'd like you to imagine a court of law with two camps of logicians. On the one side, you might have Parmenides, Aristotle, Boethius, Bonaventura, Maritain, or Barth. These are all what might be called traditionalists. Parmenides was all about seeing logic as a hand-me-down from the goddess, a simulacrum to make sense of something that could never be made sense of. Aristotle put down laws. Boethius brought them to the medieval colleges and universities, and the rest of them developed their logic in traditional ways. Bonaventura was realist rather than nominalist. So they're all in one camp. On the other side, you have the nominalist William of Ockham, Leibniz, who was all about making a calculus, George Boole and his algebra of logic, Peirce, Mitchell, I'll come back to him and tell you why he's here, and Russell with his Principia Mathematica. But things aren't that easy to categorize. Aristotle, while being in the traditionalist camp, was not averse to using symbolic forms to depict logical relationships. The square of opposition is implicit in his work and was drawn up by medieval logicians. And Aristotle himself used shorthand letters for terms. In the Greek, these would have had numerical value, and it's worth thinking about whether they were associated with numbers then or not. Maritain, who's very much a traditionalist, came up with a calculus of his own. It took into account in great detail the existential import of terms and relationships within propositions. This is what syllogism and Barbara might look like in his approach. Leibniz, as you know, came up with his own calculus, and particularly in his later work, in 715, a year before he died, he came up with symbols. And I only found this out recently. They look incredibly close to Spencer Brown's mark. But while Spencer Brown's mark is unary, Leibniz's notation is binary. He has a horizontal solid line and a vertical dashed line, and they combine to form Leibniz's mark, but it's still a binary system. But however much he wanted to have this play of zeros and ones, he was also looking for unity. But I think his symbols got in the way. George Boole, in the 19th century, wanted to reconcile mathematics and logic. And for him, one was the universe, zero is nothing. Later on, he looks at one being true, zero being false. But the problem with Boole's system, for me, comes with him treating nothing as a class. If you treat nothing as a class, it ceases to be nothing. It's a marked state, not an unmarked state. And in Spencer Brown's thing, whereas Boole has 0 and 1, nothing, and universe, neither Boole nor Leibniz take into account the mind or the piece of paper on which their symbols are written, unlike Spencer Brown. Mitchell is interesting. He came up with a symbolic shorthand form, which is one of the few, if not the only, form of algebraic or symbolic logic I've found that matches the distribution of terms very closely. And this is what's interesting in applying the calculus of indication to the notation of logical syllogisms. So where you see a line over a term, that means that the term is distributed. And there are various patterns of distribution that go to form the 4 moods. The universal negative, no A is B, means that we're talking about all A, and I like to talk about fitting all the A's in the universe into a Hat's box, distributing them so the space is completely packed with them, popping the lid on, and that's it. We're talking about all A's, it's distributed. And if we exclude all the B's, we can imagine all the B's in the universe packed into their little hat box, distributed in the space, lid on, bump, that's it. If we're talking about some A, it's not distributed, some B, that's not distributed. All A, we're talking about all A, that is distributed, is B, but we're not talking about all B, that's undistributed, and some A is not B, we're excluding all of the B's, the B term is distributed. Where does Spencer Brown fit in? It's difficult to say. Let's see. We have to go with what he wrote in the second appendix, Appendix 2 of Laws of Form, where he applies the calculus of indication to algebraic logic, first of all, and then in the second part, the traditional logic of classes. For that, read Aristotelian logic, because he refers to the traditional valid syllogisms by name, Barbara, Celer, Dari, Ferrier, etc. Now, in this talk, I want to talk about three things that have not perhaps been looked at in sufficient detail previously. The first is the distribution of terms, which I've already hinted at. And the second is the qualitative aspect of logical figures and syllogisms. This was very important in medieval logic. And in third place, looking at validation and how we do that with the calculus of indications. If we go back to the pie analogy, the distribution of terms looks at the form, the pie dish. The qualitative aspect is all about pie awards. Which is the best pie? And the validation is like a temperature probe, just checking whether the pie is cooked through perfectly. So we start off with distribution. I talked to you about how different terms are distributed in the various moods of syllogisms, but Spencer Brown deals with things mathematically. And for him, he treats negation exactly the same way as he treats implication. So that means if you have not A or tilde A implies what, B, so if we have a tilde X, not X implies Y, if we take mark over mark away and cancel that, the value of that expression symbolically is exactly the same as a sum X is Y, which doesn't work for me. I want things to be very clear and not ambiguous. So what I proposed in a previous paper I wrote showing how the calculus of indication can be used very fruitfully in the practice of classical logic is this. If you keep the mark as a mark of distribution and you keep the tilde as a mark of contradictory terms or negation of a term rather than negation of the proposition, the relationship between the terms, then you've got a very, very clear system. It's not confusing. And everything is in its place and everything works out. Distribution is not the same as negation. And this reconciles Spencer Brown's work with the spirit of classical logic, which is all built on the distribution of terms, and that's what the different moods of propositions are built from. What about the qualitative aspect? Who wins the Logic Pie Award? Well, this is where we come to the medieval mnemonic rhyme. And there is a secret code to this. And the code is this. It's based on the belief that figure one was where you have three terms in a pair of propositions, A, B, and C. If you start off with two of them, A and B, and repeat one of them, either A or B, you get various patterns. C has to go somewhere. Figure one was where you can read all A is B, all B is C, therefore all A is C. It flows, and if you do it in that order, with what they call the minor premise followed by the major premise, then the terms of the subject and predicate that are in the two propositions come out in the order you have already presented them in the conclusion. It's beautiful. And what's also clear, which we'll see later on, is that if the middle terms are in a marked and an unmarked state, which you can clearly see with the marked distribution over them, then they can be cancelled out, and you can just see intuitively, visually there, that a proposition will either work out, the syllogism will either work out or not. Now, we've used the letters A, E, I, O to mark the moods of syllogisms. We've used the first vowel A. The next letter is B, C, D. We've used the E, we can't use that, so we go to F. And B, C, D, F are 4 syllogisms in figure 1. They all have that pattern of letters. But where you see the vowels in the words, they denote different moods of propositions, and that's where they differ. And the whole point of this rhyme was to strive for perfection, because they believed that the syllogism in Barbara was the perfect syllogism in the perfect figure. No other syllogism yielded a universal positive conclusion. So this rhyme was all about getting to perfection, winning the logic awards, getting your argument to be as universal, as perfect as possible. And to achieve that, they used coded letters, S, M, P, C. If you found an S, and I've translated the mnemonics to English, we switch terms in a proposition. And that works with the universal negative and with the particular positive, the E and the I propositions. If you find an M, you move propositions, you switch them around. If you find a P, you put up, you elevate a particular to a universal positive, or put down, denigrate a universal positive to a particular positive. And for the C, you disprove by contradiction. There's a mnemonic that helps me remember the letters that have no significance: bed, Leon, rest, BD, LN, RT. So the first figure ones are Barbara, Celarent, Dari, Ferio. And if we put them in the order of minor, major, conclusion, they look like this. We have to take the first one from the middle, the second one from the left-hand side, and the conclusion stays the same. And that's what they look like. So here an E proposition in Celarent, both terms are distributed. The A proposition in Celarent, only the subject term is distributed. You can cancel out both middle terms, which is why they're shaded green. One is unmarked, one is marked. And you move the subject term to the conclusion, that's A mark, and the predicate term to the conclusion, that's C mark. And there's your conclusion. So these are the 4 second figure syllogisms. And where they have a capital C at the beginning, they can be converted to a Celarent syllogism. Where there's an F, it converts to Ferio. Where there's a Barocco, it converts to Barbara. Here's what the figure 2 syllogisms look like. So they all start with AB. And in figure 2, you move the B term to the second place. And C goes first. And then all that changes is the moods. Again, we're reading this way if we read the Latin names. So let's look at how Cesare converts to Celarent. We're in the second figure. So we start with AB. Second figure moves the B to the furthest position. And we know our conclusion is going to be formed by any terms which are not the middle term. This is the mood E. This is the mood A. And this is the mood E. That's EAE2, Cesare. we want to move it to EAE1, Celarent. And the code says switch the terms in the E proposition. So we do that. There we go. That stays the same because bed, Leon, rest. The R has no effect. And there we go. It's a beautiful flowing figure 1 syllogism that actually works more perfectly. In the third figure, we have a pair of controversially valid syllogisms. Here, the A term is repeated as the middle term. It moves to the nearest position, and the moods then change. 1, 2, 3. And we're going to look at one of the controversially valid syllogisms, Darapti, which is an AAI3 third figure, which means we move the C to the furthest point. We need the A, and the I does not have any marks on it. And here, the P tells us we're going to put down A to I. How does that work? You don't change this because the first A term has no letter affecting it. That's the one that changes. And this shows that we have a middle term which is now unmarked and marked. There is a reason why this works. It's one of the controversially valid ones. And if we switch these terms around, we have a beautiful figure 1 proposition, and that works. Dari. Disamis is an accepted valid one. Again, figure 3, A, sorry, I, A, I. Yeah, so the I, the first one is in the middle. And here, we've got a shift and a move. How does that work? We shifted the A and the C terms, and we're going to move them so that the second proposition is first, first proposition second. Again, a beautiful figure 1, and we can derive a conclusion from it that's valid. Last one, Boccardo. Now, this is important because in laws of form, Spencer Brown spends a long time showing how if we start from Barbara and take his notation, which involves crossing 2 propositions individually and jointly for conjunction, and then crossing them again for implication, and then removing the pair of marks and switching them around, it's almost like a conjuring trick. He renders Boccardo and Barocco from Barbara. And he calls it a transposition. Now, his conclusion from doing that is that we see that the representative form of the syllogism in Barbara is also the representative form, remembering that we have in each case put what is called the minor premise first, of syllogisms in Boccardo and Barocco. The 3 syllogisms above being effectively reducible to the same mathematical expression must therefore represent at this level an identical form of argument. Well, not for me. There's a conversion, there's a qualitative aspect where Barbara, for the medieval logicians, was superior to Boccardo and Barocco. And the only equivalence is that they are diametrically opposed on the square of opposition. An A proposition has a subject term marked and a predicate term unmarked. An O proposition has a subject term unmarked, a predicate term marked. So as soon as you put a mark over both terms, you switch the mood. And that's all that's happened here. So what would the medieval logicians do? They would take a third figure, which involves moving A to the nearest space and then putting the C afterwards, deriving inclusion. Let's mark the moods, O, A, O. And they would say we're going to disprove by contradiction. Now, this is the way I do it. I take I want to disprove the B C mark, the some B is not C, by showing that an A proposition is false. Therefore, the O proposition must be true. So I want to get to an A proposition, all B is C, in my conclusion here, which means I need to start with a marked B term and have an unmarked C term here. I'm converting to an AAA1 proposition, a syllogism, sorry. I can cancel out my D because one is unmarked and one is marked, move the subject term to the conclusion, move the predicate term to the conclusion, and I've got an AAA1. If this comes out to be false, then I can prove the conclusion to be true. That's one way of doing it. There is another way, but that should have showed you the difference between the medieval approach qualitatively and Spencer Brown's. Just for the sake of it, we'll look at a fourth figure. These two are blue because there are two controversially valid ones. Again, we go 1, 2, 3. And we're only going to look at Brahman tip here, just for the sake of it. Here, A goes to the furthest point. We get the conclusion there, which is not the middle term, A, I. And we're being asked to put the I to an A proposition. So there we go, that's the A. Because we need it in figure 1, we're moving the propositions. And that's where the conclusion moves from I to A. You can see it works. So the medieval approach was all about the relative perfection of figures. Figure 1 was the perfect figure, and AAA1 the perfect syllogism. Why? Because it was the only figure that could yield an A-form conclusion. The only syllogism that could do that was the Barbara one. Figure 2 could only yield negative conclusions. There's an exception where one of the premises is a definition. Figure 2 is particularly adapted to disproof. Figure 3 can only yield particular conclusions. And figure 4 we don't really need. You can convert or shift things to make all the valid syllogisms in figure 4 into superior figures. We don't really need it. And that's something that Spencer Brown's system doesn't really take into account. But it's how logic works, or how the medieval way of doing logic works. When we come to validation, Spencer Brown showed that by using the calculus vindication and the consequences, he could very quickly work out whether a syllogism was valid. His approach was to use various iterations of C1, C2, and C3. Now, John Mingers worked on Spencer Brown's Appendix 2 and found problems in the way he looked at it. Prior to that, I'm not aware of anyone having done that, apart from Lou, who showed through his syllogistic wheel that you could derive all of the syllogisms valid in classical logic from Barbara. But there are no O propositions. Everything is converted, and it's not as elegant as it could be using the calculus. So what does John Mingers do? Again, let's take this AB from the middle, put it first. We've got BC there. AB is crossed, BC is crossed, and they're both crossed. That's conjunction and implication, and we get the conclusion. That's how Spencer Brown presents it. Now, if we apply C1, those disappear. If we apply C2, we take the C in the conclusion and cross out any matching term which is underneath a mark. Same with the A mark, that crosses out. We're left with B mark, B, mark over mark. The B mark cancels this B mark out, and we're left with an empty mark. If we have an empty mark, then we can cancel everything else out, and by Spencer Brown's rule, this syllogism is valid. What Mingus found that in some of his notations, and he used a two-level notation, that this didn't work. So here you've got a pair of propositions. B is marked in both cases. It shouldn't be valid. We've got the pair of marks for the conjunction here. We've taken the second mark for the conjunction and the implication off. We've taken those 2 marks off, and we can take this B mark off. We can take the C off. We're left with an empty mark. That shouldn't be valid, but it is in Mingus notation. But if we reduce the notation to 1 level, you don't need to have these 2 marks. These are marks which can be put on just for validation. And for me, they don't have any significance beyond that. They don't have a significance of implication. They don't have a significance of conjunction. They are just marks of validation. So if we run these things and do them in order, if they work, they work. If they don't, we skip them. We can see that all A is B, all B is C, therefore all A is C. We put the marks of validation on the 2 premises, not on the conclusion. We use C2 to cross off the A mark here and cross off the C here. We're left with B mark over mark, A mark C. We use C1 to take the mark over mark off the second B term. We're left with B mark B, A mark C. The B outside the B mark cancels the B inside the mark. We're left with an empty mark. You can't do J1, therefore by C3, anything outside an empty mark you can get rid of. That's valid. AAA2 we know is not valid. The same approach doesn't work. You can't reduce it to an empty mark. The system works, and it works for all the classical syllogisms. For J1, if you come across it, you treat the C and the B as both marks. They're both equal to P mark over 2 in the classic J1 thing. So that's where this interpretation actually matches. A term is a term. It's a mark in the mind. Now, you don't need to go through C1 in Spencer-Brown's system. All you need to do is add a mark of validation, and you can go through. If you've got an A proposition and another universal, it could be an A, it could be an E, and a conclusion, which is a particular form of whatever other proposition is with your initial A term. So if it's an E, it's an I, it's an O. If it's an A, it's an I. Then all you need to do is apply C2. If you can do that, you have a mark of validation there, which allows you to cross out the C. You're left with mark over mark. Yay, works. AAI2 doesn't, it's invalid. And again, you can test this out yourself. It actually works. So for me, laws of form, even though I don't agree with Appendix 2, can provide a beautiful, minimalistic, visually intuitive way of working with classical logic. And in the spirit of classical logic, which is qualitative and aimed at bringing us to a universal understanding, just as laws of form does when linking to Chinese philosophy, there is something very beautiful in the approach. And that something is revealed if you translate the terms to marks. What you have then is pairings of the unmarked state and the marked state, which can be mapped to the diagrams in the I Ching. And there's a whole piece of work I've looked at in a presentation I gave to Rilke a while back, which you can watch in a video on YouTube. But it does link to something that Leibniz was hinting at. I think this comes from his De Arte Combinatoria. It's the frontispiece to that, where he's got the elements around this supposed square of opposition. And that maps beautifully to the way that the Chinese 5-element circle works. And I've done quite a bit of work on that, but that's another story for another time. When I see things like this in books like Russell's Principia Mathematica, I just feel nauseous. I don't know what they mean. I just can't do it. Compared to the visual, intuitive approach that Spencer Brown's calculus gives, this, well, all I can say is I agree with the pudding. Who would be a pudding in a pot? I hope you get the stomachache for eating me a lot. I hope you get it hot, you pudding-eating lot. And that's what I think logic says to algebraic approaches. But when it comes to Spencer Brown's approach, I think there's an argument to say that Spencer Brown manages to reconcile the best of both worlds, the best of the classical tradition approaches and the algebraic approaches, and he achieves it through the beauty of his unary calculus. Bon appetit.
Brilliant. Thank you, Leon. Can you stop sharing your screen, then we can see each other?
Yeah.
And,
I just need to go back to this.
a bit.
And stop share. Done.
There we are. Lovely. Well, there we are. Any questions? Barbara? No, sorry, that's a joke.
Hey, Lou.
Lou. But Barbara may have a question. Lou.
Yeah, a couple of comments. In the chat line, I wrote a short paragraph explaining the Spencer Brown point of view from my point of view. I won't say it out loud, but I do want to make the following comment: that if we take cross A, B as all A are B, if we take that, then cross AB, double cross AB, which is just AB, is interpreted as all not A are B. So in the Spencer Brown point of view, A next to B is interpreted not as some A or B, but all not A are B. And this is where Leon's transcription of the logic diverges from Spencer Brown. So if you're making a comparison between the way Spencer Brown works and the way Leon works, that's the pivot.
Yeah, that's a fair comment. If you can work in that system, then all grist to your mill. I can't.
Oh, I'm only talking about the comparison. One can work in your system, one can work in another system.
Okay. Anybody else?
I'm interested in the. I'll start the video after I've made my cup of tea.
All right.
I'm interested in the historical stuff, Leon, and it's made me realize I really want to look back at that. I was really interested in what you said. I hadn't realized, because I haven't gone back to original Aristotle, that he actually used these shortened terms. So I'm very interested in looking at that, obviously, because of, in terms of the development of mathematics, symbolic mathematics really came into being around the year 1600. In fact, this colleague of mine, Martin Lowe, who we published last year, and hoping to publish this year another paper of his, he unfortunately passed away across the threshold a couple of years ago. he worked with Francis Yates, and he reckons it was like the actual crossing, you know, that like it came together with the algebra in around 1600. But I'm very interested to look at all the sort of, you know, previous ideas of that. So thank you very much for that. I'm not sure that there's a question. No, I obviously, I'm going to have to go back and look up, or, well, obviously Mark will send the PowerPoint over, so that frontispiece of Leibniz's Ars Combinatoria is beautiful. So just yeah, so thank you very much for all these, basically.
If you're interested in looking at the classical way of doing the logic more closely, it's different to algebraic logic. Look at Sister Miriam Joseph's The Trivium and Jacques Maritain 2 books of logic, Introduction to Logic.
Yeah. Lou.
Great.
I'm interested in the reference to Leibniz. Can you give the reference where that symbolism of Leibniz occurs?
Yes, I can. Let's go back to the slide. Here you go.
Thank you.
Okay, Peter Marser. Peter, you're muted. There we are.
I'm interested in this problem of the undue effectiveness of mathematics as it applies to physics, which could be, of course, taken the other way round. In my view, what is the ineffectiveness of what is the undue effectiveness of physics in relation to mathematics? Because clearly, when the universe started, and if there's only one symbol, then it self-organized its own laws, and it would do this in a physical way, not necessarily a mathematical way, until it happens that in very, very late in the evolution so far, the human brain mind comes along and discovers that it is a very efficacious way of predicting what might happen in physics, and then doing an experiment to prove that it actually does. And if you get the mathematics right, that sometimes happens, but not always. So can you,
being neither a mathematician nor a physicist,
can you shed any light on why there is an undue efficacy of mathematics when applied to physics?
I can't, because I'm neither a mathematician nor a physicist, but it seems to me that the assumption that mathematics only comes in with the human mind belies what is at the heart of the Taoist philosophy of the yin-yang forming a triplicate one, which gives rise to 2, which gives rise to 4, which gives rise to 8, which gives rise to the 10,000 things. Isn't mathematics at the heart of that?
Well, would you think that really mathematics, in some sense, is just another language, like the semantic language we use? Well, I'm using now, which is called English, and it's very much my English.
I think there's an underlying commonality, which is what Spencer Brown reveals so beautifully.
Yeah,
With the
I completely agree, but it would be nice to understand why. I know that the current paradigm says that in fact mathematics is a sort of separate something that seems to have come before everything else, from which you can work out how the physical world operates. But I say there are reasons to doubt that, and to believe, as I firmly do, that in fact mathematics is just an invention of the human mind, which works entirely physically.
It could be. Spencer Brown's says mathematics is what we. What is it? What is that quote, Lou? You know it better than I do. Mathematics is what we make of what we know, or something. I'd have to look it up.
Sorry.
Mark?
I'd be very interested to hear Lou's
okay, so Lou's next to ask a question, so maybe he could address that. Who's just called my name? Sorry.
I did. It's
right,
Michael.
sorry.
Yes,
Right.
unfortunately, yes, nice. Unfortunately, I don't have a means of showing a picture. There's no camera connection here. But let Lou ask his question. I wanted to come in on a remark that Nicola made, but please let Lou go first.
Okay, all right.
I'm up.
Yeah.
Well, I just want to make the remark to Peter that when you're looking at mathematics versus physics, you're working two sides of one distinction, the distinction being physical and non-physical. You're working the two sides of that distinction, where the mathematics is on the non-physical side and the physical side is the physical side. And that these two should end up being related to one another is not so surprising, given that the two sides of any distinction are going to have to be interrelated.
Well, yes, but I think it would be.
But this is a very, very fundamental distinction that we're talking about.
Yeah, yes. I completely agree. And it may be just me, as I'm somewhat physically intuitive. When I really only understand my mathematics when it describes some physical process, and I can think of it in those particular terms. So I don't get any kick at all out of pure mathematics.
But when you make a distinction, you have to agree that it certainly is physical. It involves your whole body mind.
Oh yes.
And then you see how you boil off symbolism from it. You have summarized it. You have abstracted it. You have taken it away from the physical, but you don't quite manage it. You don't actually manage it. And yet, on the other hand, on the non-physical side, the mathematical structures have their own reality, because you have that distinction between the physical and the non-physical. The number 3 is not physical, but all the instances of 3 are physical.
No, the number 3 is physical. It's a symbol.
No,
Symbol
it is.
a symbol.
Well, if you drain the being of 3 down to a symbol, that's where you then create a mystery, because P3 is a certain being for you that is alive and not physical.
Well, no, I don't
Or
agree.
beyond the physical.
No.
It encompasses both sides of that distinction.
It's not necessary ever to get beyond the physical.
Where in the physical world is the number 3? Where? Where is 3? Where? Show me 3.
Well, I just write 3. I just write a symbol on a piece of paper.
That's an instance
like
of
3.
3. That's a symbol. That's not 3.
It's confusing the symbol with the thing symbolized.
Yes, surely. Can I just enter a point here? I actually wanted to follow up the historical point which Nicola made, But just on Lou's point, I mean, surely Peter would concede, as a physicalist, that for him there is a fact of the matter, whether there were 3 dinosaurs in a particular watering hole, sometime in the Jurassic. There certainly weren't symbol-writing creatures around to record that fact. I mean, I think any attempt to reduce the ontological status of numbers just purely to the fact that we are able to create symbols for them is hopeless, and was long ago demolished by Frege, for instance, and others. But what I wanted to ask, Lou used a wonderful metaphor a few moments ago about was it boiling off the symbolic content from the
I won't try to repeat it.
It was no, but it was for me. It was very profound, very illuminating metaphor. I must go back to the recording and remind myself exactly what it was. But it was something about boiling off, and you put your finger on something absolutely fundamental, which does actually relate to the point I wanted to make about Nicola's historical question. There is this profound question of the so-called symbol grounding problem, which has been around really ever since this revolution in the 16th century. Which created symbolic mathematics, and there is this fundamental tension between the essentially diagrammatic reasoning that preceded that one sees in the Greeks, and that one might argue is being revived in Spencer Brown, but also revived in other more recent developments in mathematics itself, including, for instance, in the detection of functoriality of maps in category theory and areas like that. But it comes to this, that there's a wonderful book, since Nicola cited a couple of texts, which I really would urge everybody who may not have already read it to read. It's by Jacob Klein, called Greek Thought and the Origins of Modern, or Greek Mathematical Thought, I should say, and the Origins of Modern Algebra. It was, does anybody know this work? If not, I do urgently recommend it to you. It studies precisely this issue of what it was that happened intellectually around the year 1600, a little bit before, a little bit after, in the work of Vieta and Stepin and the first modern algebraists.
Can you write the title of the book in the chat line?
Yeah, yes, certainly will. I'll put it in the chat line. But the point he makes is that a whole understanding, for instance, of the notion of number changed as a result of this symbolic revolution. The Greek understanding of the notion of number, of arithmos, was quite different from that of the post-17th century. For the Greeks, for instance, 1 was not a number. The smallest natural number was 2, because a number was by definition for them a determinate plurality. So anyway, I mustn't burble on, but I will put the book in the chat line. But it pinpoints both conceptually and historically the source of I think, of some of these very, very subtle and deep questions about the nature of symbolic representation. Okay. Interestingly, Klein was the student of Heidegger. Anyway, as I say, forgive me for the long interruption.
Okay, Leon, and then Nicola.
I just wanted to come in with a potentially reconciliatory comment. If I'm a words guy primarily, not a numbers guy, but Spencer Brown always used to say, you won't find a number 7 under the carpet. This is Lou said that. But with words, if you look at the 9 parts of speech, when I teach them, I divide them into the noun family. So you have nouns, pronouns, adjectives, articles and prepositions. Prepositions join nouns. And then you have the verb family, the verbs, adverbs, and conjunctions. And then you have the interjections. And the interjections don't fit easily into either the noun family or the verb family. They form a kind of logos. When you say, it's an utterus, it's a verb, because it takes place through time, but it's also dependent on a noun, a person, a fixed being there to make that interjection. And it's that static dynamic principle that is at the heart of language, at the heart of mathematics, at the heart of Plato's Same Different, at the heart of the I Ching, of the static dynamic yin-yang forces, that I think we're touching on here, but
yeah.
it's a mystery.
You can think of the diagrams as a kind of interjection.
Absolutely.
I mean, how do you account for the remarkable fact that any normal human baby who grows up, it's who he just picks up language, and any language, and they can be totally different. You can have Chinese or English or whatever you like. He picks that up very easily, and very shortly is using the language in order to coexist with his fellow human beings and other things. Why is that the case? I think that I can actually give you an explanation, and that's one of the things that I'm going to do when I speak.
Good. Do it now.
So I'm not going to do it. I'm not going to do
Okay.
it now because it takes a long time.
All right.
But it's associated. It's associated with holography and holograms.
Right.
Interesting. I would be interested in seeing how that.
If you look at any object on the desk in front of you, you will actually discover that it's an object by touching it. And where is that object? Well, if you reach out and touch it, you'll discover it is exactly where you see it. And if it makes a noise, it will be exactly where the noise will come where the noise will come from. And the arguments I would employ are all concerned with those really fascinating facts. I mean, any object in front of you is to some extent in space in a unique place, and it's where you see it, and it's also where anybody else who comes into the room will also see it. So it's the objectivity of the object as you perceive it through your various senses that actually is the means by which we all communicate. We can all communicate with one another, because otherwise our experience is wholly is somewhat subjective. But because we have the objects around us and they're all in essentially unique places and are all, in some cases, unique as we are ourselves, then that's what makes human communication objective, because I can tell you what my experience of a telephone is, and you can tell me yours, and we will recognize from our experience that. But if somebody was as can happen on weird programs like Netflix, is killed with a telephone, okay, then their experience of a telephone, if say they were just injured and didn't die, then would be that it's not. It could be horrific.
Yes, absolutely.
And this is what we're doing to ourselves when we go and look on the television. If you on the television, if a child sees one of these weird things that has been invented, which may not ever be possible physically, or sees a murder on television, then because it's been simulated, then as far as they know, it's real. And this is why we've got a lot of the mental problems that everybody has now, and why children are growing up in a way that is really questionable. So we've got to be it's very fundamental to understand this particular thing that I'm trying to explain.
I'm really looking forward to your talk. Peter. That is absolutely fascinating. Now, Nicola has been extremely patient, so I'm going to let Nicola talk. Then Lou has got another question.
Okay. I mean, I totally agree with you, Peter, about what you were just saying. It's the dangers have not been appreciated, and the fact that we have all the, that there's still all these drones going over, killing people, over in Pakistan, Bangladesh, Afghanistan, whatever, is because it's like computer games to the people who are doing it, and it's all absolutely terrible. And as I said, it's been all downhill from the Pythagorean school being broken, because mathematics is very powerful, and within the Pythagorean school, it was a spiritual personal developmental school, so that you develop the responsibility to use the knowledge. And there's more. Obviously, I quote, thank you, Michael. I quote Jakob Klein quite a bit in my history of the changes of the concept of number, which is in one of the Anpa proceedings. I can't remember which one, but that's also, you can just look online for that as well.
I certainly will. Thank you, Nicola.
Right, great, okie dokie. And now then, so going back to, if you remember, this question of the nature of mathematics, and you're saying that it's a language like any other. I think on the chat, John Torde was talking about it as a meta language, which I think interesting.
Meta language.
Yes. Yeah, if you could let me finish, please. So I think it's actually both, but I think the important distinction from other languages, I mean, it's to do with, what Lou was saying about being boiled off and the abstraction. And it's one thing that I've been writing about, which is that in normal language, I follow Whitehead in that we can really only use description, whereas in mathematics, we do use definition. Mathematics is the most rigorous language that we have. That's what we go and that's the meta language.
Well, I will agree with you, but as I say, I'm very interested, because I think we have to, if we're going to explain how the brain works according to how we observe it scientifically, then we need to answer this particular question. I mean, why was it, for example, that oh gosh, I forgot inside the neuron, okay, it follows it's an incredibly complicated structure, so that when the neuron fires, okay, it enters into the signal enters into the synapse of the neuron, and the synapse of the neuron contains a vesicular grid of that contains particles, and each of these particles is a neurotransmitter, and they're inside a vesicle that contains 10,000 molecules of neurotransmitter, and they're released probabilistically across the synaptic grid in particular circumstances. Now, why would nature invent such a complicated way of doing things, particularly physically, when you'd expect the physical mechanism to be as least complicated as possible? But nature has invented it that way, and that is actually as it's observed in nature, and there are endless billions of us on this planet at this particular moment, indulging in neural events, and they're using this particular structure in all of them. And that's something that that neurobiologists have to explain. Why did nature create this incredibly amazing structure to do our neural works? It's not just a question of having a 1 and 0. No, it chose this very, very strange way to do it, and I can see why this happens to be the best way to do it. And then you can produce mathematics which explains why that's the best way to do it. And my colleague in Germany, Walter Schremp, has done just that. And he's also explained how magnetic resonance imaging machines work. And he's been a consultant at places like Harvard and MIT, discussing with them how they could make MRI machines work more effectively. And the tool he uses for this is holography, but quantum holography. So it's not a question that quantum holography doesn't work. It actually does work, and it's applied in machines that human beings have made, and it can do amazing things. And we probably, a lot of us here, have had an MRI scan as part of the diagnosis of specialist doctors. And that has helped to actually cure us in some cases. Myself having had experience of it. I've actually sat on the operating table, and in order for the doctor to discover whether I had a cancer in my kidney, he actually stuck a probe through my stomach wall into the cancerous cell, and took a sample, and then it came out and did a biopsy. And he did that while I was talking to him about how MRI machines work. So it really is quite amazing when you're there and you look at the screen, as I'm doing now here, and there's a probe going into your stomach, taking a sample from the tumor that he's managed to locate using the machine.
Okay. Well, it is extraordinary. Lou, you had another question, didn't you?
It's muted. When after Lou's unmuted and asked his question, could I just put a question to Leon and Nicola?
Sorry,
Yeah.
Go ahead, Michael.
Oh, yeah.
Yeah.
Or you want me? All right. So I was just saying that I think that Peter puts his finger on something very important, that objects for us become mutual agreed upon observations, mutual fixed points for our observational structure, and that this occurs in the physical world in such a way that when I hold up this stylus, you probably all understand that this is an object. It's not my hallucination. But on the other hand, if right now I was having a visual migraine, I could tell you how beautiful and colorful it was, but you wouldn't agree that it was an object in the world. On the other hand, I can say things to you like the sum of the squares of two consecutive Fibonacci numbers is a Fibonacci number. And having said that, you can verify that I have told you something objectively true.
Yeah, no,
without the without the intermediate of the physical sensing. So we have this skein of mentation and agreement on experiment that goes through and through everything that we do.
Yes. Well, I like the metaphor, for example, that appeared in this in this film Kunta Kinte, which was supposed to be based on true fact, where when his son is born, he raises the child into its air to look at the sky, which is the African sky, which contains the stars and really the galaxy that we live on, and says, "Behold, the only thing greater than yourself." And I think that's really very true.
Okay. All right. I've got a question, Leon. You mentioned Jacques Maritain. You mentioned Jacques Maritain. Oh, Michael.
No, it's quite okay. You go first, please. You ask a question about Maritain. No, not at all. You go ahead, and then I'll ask the question to Lou and to Nikki. Well, it's a general question.
Okay, thank you. Sorry.
Not at all.
You mentioned Jacques Maritain, Leon, and he's someone I was fascinated in because of the sort of Bergson connection in his work, and it makes me wonder: do you see a sort of a Bergsonian or temporal dimension in Spencer Brown?
You would have to explain your understanding of the Bergsonian thing, because that's not on my radar.
So, I mean, so what does Maritain do? He brings together a sort of a Bergsonian epistemology with medieval logic, particularly Aquinas. And so that's all about time. It's all about the experience of time. Now, I don't see, I mean, obviously Spencer Brown has got time in his network diagrams and the way that works, but in the logic as you presented it, I don't see time working in quite that way. So
why would it?
I'm curious as to where you, because you mentioned Maritain also in the discussion as well. I'm interested as to where you see that fitting in.
Where did I mention Maritain in the discussion?
Just when yeah.
No, go on. Where?
No, I can't remember whose question it was. It might have been Nicholas. You mentioned him as well.
I just mentioned that the two influences on me in terms of reconstructing classical logic were Sister Miriam Joseph and Maritain. And okay. I think her work was influenced by Maritain.
Okay. You haven't thought about Maritain so much?
I haven't thought about Maritain so much in his wider thing. I'm not familiar with Bergson. And the question of time and logic, well, for me, it's just like story. You can expand and contract. Think of a sorites and its contraction into its basic conclusion.
But also, when you bring the logic down to individual symbols, the individual symbols are not static, actually. Yes. They are processes in which you are participating.
Yes.
Yeah. And as soon as you pair terms together, something happens. Does a term exist? What's the quality of time that a term exists in? What's the quality of time that a syllogism is? It's like a question I pose my students sometimes. 2 + 2 = 4. Where's the verb in the equation?
What, are you asking me?
Yeah.
Well, equals, I would have thought.
Why not the plus? Isn't the plus where you
put it
together?
There's
no right or...
Mathematical language is mathematics has a different grammatical structure. This is really important to get that. Yeah, because they are both. The plus is, and we've had this coming up before, in like in Mike Manthis and your work, Doug Matsky, about when you're looking at the plus and you're saying, no, this isn't just a simple plus. I mean, it's in laws of form as well, but you know that it's superposition. That there's a different sense. But it's really important to understand that when mathematics became symbolic, it was a quantum leap, and it's a different kind of structure. And looking at that is really interesting, and that's something that I've begun to do, and yes. I'm sure I'll be talking more with Lou about it.
There's not just one kind of mathematics, and there's not just one kind of three, for example. So
exactly.
So if we're talking about so Lou is putting up a challenge as to, you know, what's a physical three a little while ago. What is three? Where does it come? Well, three in some senses is the only thing, because you're sitting in a three-dimensional universe at the moment. There's a three there. There's a symmetric three, which one could take as a shape as well. And in fact, the numbers were originally made to have points. So the 3 has point, 3, 4 has 4 points, the 2 has 2 points, and so forth. These things are things which represent in their nature of the symbol the reality of that number. And if you think about, you know, how important 3 is, I mean, it is utterly fundamental. It appears everywhere.
All the triples, you know, add to the concept of 3 that you have.
That's
so
right.
Russell is not wrong when he says that 3 is the collection of all triples. If he takes collection to mean a unity of the Cantorian kind and not of a symbolic kind.
Yeah, but he's not wrong, but he's not wholly right either.
Exactly.
So John, that collapses.
Okay, I'm going to return to being a good chair. I'm really sorry for not asking Mike, but Mike, your question now.
Yeah.
Not at all. Well, I think.
Lost you. That's typical, isn't it?
Naturally fits into the exchange. Sorry, can you hear me now?
Yes.
Oh no, can you hear me?
Yes.
Yeah.
Oh damn! Can you hear me?
Yes.
Yes. Unfortunately, my connection is very unstable. It's breaking up, but you can hear me now.
Yes.
Good. Okay. Quick question then. Yes, the issue of the relationship of mathematical symbolism to time, I agree, is a very, very deep one, and I was fascinated by Lou's remark that ultimately we have to have some kind of process-based account of the symbolic content. But that raises very deep issues, which I think are really too profound for me to go into here. What I did want to say is that as we're on the way at the genesis of semantic content in general, I would stress the importance. This is a theme which has been developed a great deal by an Italian philosopher, Alberto Peruzzi, who's been a very big influence on my thinking, actually a close personal friend. And that is the profound role of topological and geometrical structure in the very condition of possibility of the formation of semantic content. Leon mentioned his teaching natural languages and groups of grammatical categories, and he mentioned very much en passant prepositions. But in fact, prepositions are very revealing in this respect. Prepositions are, it is, I think, an empirical fact borne out by, in the study, comparative study of languages. In all known natural languages, prepositions, and in every case, a preposition, such as in, on, at, is expressing essentially topological geometrical information. Without that initial kind of topological handle on the structure of the world, I don't think we would have any of the other categories of language, or the possibility of the formation of semantic content, and it's arguable at least that this is at the basis of the formation of symbolic content as well. Now, this is a theme which is worked out in considerable length in Peruzzi's writings. So I just wanted to put that thought in there. Let us consider prepositions and the fact that it's topological information which is essential, integral to the content of all prepositions. And they are the very first parts of language to be acquired pretty well.
Okay, Leon?
Yeah, I find it fascinating, just coming back to that, that we say the fly is on the wall, not the wall is under the fly.
Yes, exactly. Exactly.
We tend to give precedence to the moving thing.
Yes.
That presents
yes.
the main trend. You know this.
Absolutely. There's a whole literature about this. You probably know the work of George Lakoff and his colleagues.
Yeah, of course.
Yeah. Okay, yeah. And they suggest that we can actually approach mathematics conceptually by kind of reflecting on this. Okay, I just wanted to put that in there.
Okay,
Okay.
Doug.
Yeah, thanks. You guys were talking about time and laws of form, and I'm not as versed in laws of form as I should be, but the only thing I saw about time and laws of form was that if you shifted patterns, you got the square root of -1. Is that the only place where time and square root of -1 are in law of form? And the reason I'm asking that is from geometric algebra perspective, I get square root of -1 because of a non-commutation, anti-commutative nature of geometric algebra that comes out of that naturally as a bivector. But I don't see, essentially it's a 3-valued logic in geometric algebra, but in laws of form, it's only a 2-valued logic. It's like the mark and the not mark. There's not a third value to get the non-commutative behavior. So if somebody could discuss that in that relationship between I and anti-commutative and stuff like that.
Well,
Lou.
I is very useful because it's a new kind of number, and if you're dealing specifically, for example, with waves, then the algebra of waves, then it provides you immediately with a solution to all such.
I was hoping Leon had a comment about that too.
Wave phenomena.
Peter,
Lou,
I was hoping
Lou
Leon
has the
had a
answer to this question.
Hmm?
Lou knows.
No, probably not.
Yeah, I mean, I was hoping Leon, since it's his talk, I was hoping Leon had a comment about it, but maybe Lou is the best one to answer. I'm sure what you're saying is right, Peter, but I was hoping that Leon could comment.
Yeah, Leon.
Okay.
All I'd say is oscillation comes in before the recursion in laws of form. I think that's where time starts, and then memory comes into the system. But Lou knows that bit better than I do.
That appears to be correct from the model I have.
Okay, Lou.
Have we lost Lou?
No, you muted Lou.
Sorry, the mute goes on and off. When you begin with a distinction, there is an oscillation. As Spencer Brown says, in the first place, you can't tell whether one thing is distinct from another. As distinction arises, oscillation of a more direct kind arises. Is there a... Oh, I see. It's Mike Wright's blank screen. Yeah.
Sorry.
So when you have just a distinction, then you have the possibility of going back and forth across its boundary, and then you have time there. Later, Spencer Brown talks about reentry, where that becomes a little bit more formalized, and paradox, things paradoxical, where something is equal to its own negation because you tunneled from one side of a distinction to another.
Yeah,
and if you tunneled from one side of a distinction to another, and you want this to make sense, then you can say that it makes sense in the condition of time, where something is oscillating from one side of the distinction to the other, or the distinction is oscillating, or every time it is in one state, it is forced to be in the other state, and you have that oscillation. If you then look, now comes a further story. If you look at the oscillation itself, then it has two forms. It has the oscillation from marked to unmarked, and it has the oscillation from unmarked to marked. If you think about them, they are like I and minus I, or precursors to I and minus I. And if you then examine that carefully, you see that Clifford algebra arises quite naturally out of that, and fermion algebra arises quite naturally out of that. So that the square root of -1 itself arises, at least for me for the first time, in the split quaternions, in the Clifford algebra that arises there. As a product, as a nexus, it's a temporal nexus of something which goes from marked to unmarked, made temporal, so that when it interacts with something, it also flips it. But that's a story, of course.
Yeah.
And but I think it's an interesting story because you can see how, starting from the fundamental idea of a distinction, you get to the structures of Clifford algebra and all of that almost immediately.
Is there a paper that connects those two? Because that would help me.
Yeah, I can send you some papers.
That would be great, thanks. Because I think the mark distinctions from Clifford algebra, I mean from laws of form, is great. It's just I've been so focused on geometric algebra that I don't know how to connect them. So yeah,
What's very
and Leon maybe had. I mean, again, this is
sorry. What's
I'm
differential?
hoping that he has a comment on that too, if it's appropriate. So.
Who's talking now?
Can I just come in super quickly to ask, just to say something about Lou's last remark? What Lou just said then is very illuminating, especially from the point of view of explaining a little bit more about what he had in mind with his remark about connecting symbolic content and symbol using activity with the notion of process, which he was talking about a moment ago.
Yep. Agreed.
Yeah.
Barbara has to go in a second, and I just want Barbara to say something very quickly about what she's going to talk about on Monday.
Right. You must have seen the title Zen and Environment, which says everything and nothing. So I decided, looking at the conference, that I want to talk about something like the subclass of that, which is the coded language of Zen. And I leave you at that.
Thank you.
This comes on Monday.
I'm really looking forward to it. Thank you.
Thank you. Sorry, guys.
No, it's okay.
Another obligation
Yeah.
you must fulfill.
Yeah.
Okay.
Well, it turns out you're a very important person here. So.
Yes. Very embarrassingly so. Okay. Thank you.
Right.
Thank you, Leon.
Okay.
Bye.
Okay. Bye-bye. Have a nice weekend. John Torday.
Yeah, I'm a little bit out of my element in this lecture, but I did want to say that in my reduction of all of this, we know that the poems implicate existed before the explicate. We are what biology created the explicate. So the mathematics and the physics existed before the biology. But once the biology comes into place, it is what integrates the physiology, the physics and the mathematics. And I think it relates to what Peter was saying about about children watching, imagining versus actually experiencing. There is a schism there, and you have to use the constraint of the biology. And I've said that the cell and the atom are homologs. They're both deterministic and probabilistic. So there is a nexus there that can be used to bridge that gap.
Leon, do you want to respond or?
Seems perfectly reasonable to me. I don't have anything to add to that.
Okay. I can see Art Collins there. Art, it's good to see you. Do you have a question? You're muted, unfortunately. Can you?
Hi, Mark. Thank you for thank you for seeing me here. Gosh. I gather, Leon, that your dissatisfaction with Spencer Brown's approach to the syllogism, to syllogisms, is kind of a matter of personal distaste. Is that? I mean, you seem to be pretty strong on that point, and I find the whole syllogism approach to be a little hard to follow, generally compared to the algebra is very nice and I'm very comfortable with it. When I step into the world of trying to interpret things based on syllogisms, I immediately become confused. So I'll have to spend time working through what you presented there, but I wondered, just you came across very strongly as feeling that Spencer Brown's take needed, at least to comply with you're talking about, needs to be revised. So I just wonder if you have anything more to say about that.
Yeah, I feel I may have said something like somebody criticizing Mozart for having too many notes in his music or too many instruments in his orchestra. I don't know. I'll leave it to somebody else to prove me wrong. And if they do, then it's all grist to the mill. It all goes to show how powerful the calculus is, and that's the main point here. Personally, I feel, you said you feel good about the algebraic stuff. I showed a page of symbols which are incomprehensible to me from Russell's Principia Mathematica. I'm sure that if I spent a few hours actually trying to work out what they mean, I would be able to figure it out. But with Spencer Brown's approach, if you simplify it, and Spencer Brown was all about simplification himself, and apply the marks in line with the classical approach to the distribution of terms and how that results in the different moods, the four moods of propositions we use to form syllogisms, then that for me has a beauty that links to a universality in the system, which makes it sing for me. That's all I want to say. I don't get the same thing from those symbols on the page. They're not visually intuitive for me.
Well, that was part of your presentation that I was challenged to follow from, was exactly what you were meaning by the distribution of terms, actually. Would
Did you get the bit about the hat box, Art? It's counterintuitive to a mathematician, where you have, if you're distributing something, you've got a bag of sweets and you're distributing the sweets equally among the people. It's totally different in logic. When you distribute something in logic, you have to think about packing things into a space and distributing the contents equally. You firmly press it like bread dough into a tin, and you want to get as much of the bread dough into the tin, put the lid on. That's where the bread analogy doesn't work anymore. But imagining a goo fitting into a hat box, the lid goes on the hat box, then whatever's in the hat box, the contents are distributed in that space.
I certainly understand that concept, and I know how the distribution laws work, both in logic and in Spencer Brown's version. In some of the explanations that I saw that you were writing up, it wasn't immediately clear to me how that was applicable, but that seemed to be the key point for you in terms of why your reworking was preferable. Mm-hmm. And I think I came in slightly after the box was introduced, though.
Okay, if you have any specific questions,
yeah,
feel free to email me.
Yeah, I will do so.
Okay, so the videos are all going to be online, so everyone can watch it all again, and I will certainly watch this one again because I found it really fascinating. Yeah. Are there any more questions?
Yeah, I have a question.
Yeah.
I guess the word qualitative is piquing my interest, like qualitative logic, and what that might really mean. I mean, because we are using formalism to very specifically determine whether an argument is valid or not valid, or other properties of other logical things that we are interested in. So I guess this qualitative aspect, because it's in the title of your talk, I want to hear a little more about that, if you would like to talk about it, Leon.
Well, it all goes back to what is behind this mnemonic rhyme, that Barbara was the perfect syllogism in the perfect figure. And there's this feeling that the perfect figure, although they didn't necessarily arrange the propositions as Spencer Brown arranges them, or Russell and Whitehead, or Sister Miriam Joseph arranged them with a minor first and a major second, where you get that flow, A to B, B to C. That sense of perfection, though, runs through the system. The Barbara syllogism being the perfect figure is a qualitative judgment, isn't it?
So
Thank
who
you
do
for
you want?
clarifying. Yeah, sorry, Mark.
Okay, no, it's all right. Okay, Lou.
This is about Barbara.
She's gone now.
Yes, but she's perfect. If we take Barbara, all A or B, all B or C, therefore all A or, sorry, all A or B, all B or C, therefore all A or C. The kind of transmutation that Spencer Brown talks about is verbally the following. If I said all A or B, but not all A or C, then you conclude that not all B or C. Because, after all, if all B were C, you would conclude the other. You can permute the conclusion to make it the negation of it one of the premises, and then you get the negation of the premise as the conclusion. We're all familiar with this rhetorically. We can do it by speaking. And I'm curious why, Leon, you say that Barbara is regarded as superior to the other ones that are obtained by such kinds of permutations. Why was that in medieval times?
Well, it was the only syllogism that yields a universal positive conclusion.
Well, because there
Of
are
the
no
50 valid
negations
ones.
in it. No negations in it. The others
Yeah.
all have negations of one sort or another. Yeah.
Or particular.
Right. And we can understand what Spencer Brown's point of view was because he's thinking, oh, well, all these can be mathematically transformed into one another. And so from his point of view, they have a commonality.
Exactly.
Mm-hmm.
Okay.
Yeah, and there's a, for me, form and content must be considered together. And
Yes.
Spencer Brown is just looking at the form, not
Right.
looking at the content.
Right. Like when we perform linguistically, we take Barbara more than all those ones with the knots. The ones with the knots are much too complicated, but we can get to them from Barbara. So mentally, we're back in that medieval point of view.
Can I ask Leon a quick question? I assume there was a theological aspect to this positioning of Barbara as the most perfect of the syllogisms. Sorry, am I?
There would have been, yes,
Yeah.
because it was within that.
Because of the
medieval
business about,
scholastic philosophy.
yes, about the nature of
being, yeah.
Yes, about the nature, as it were, perfect being, and God, as it were, not containing or reconciling all contradictions, not containing any negative. Yes, I can assume. I see that would have been kind of part of the background.
But as Spencer Brown would say, the God idea is not helpful. You don't need it to appreciate the wonderful.
No, I was simply citing it as part of the kind of heuristic that was part of the medieval outlook.
Great. Okay, are we? I suspect we're done. Oh no, Sahu.
Sorry, I didn't want to hold people up. This was a general observation I had when I read Laws of Form by myself, and I didn't have anyone to talk to about it for a couple of years. And I guess I was a little confused because within Laws of Form, he uses logical structures, like he does say if, then. He does write proofs and write, and there is an implicit logical understanding in his communication, which for me was kind of confusing at the beginning because I did not have I did not have people to talk to clarify or sort of understand the heart of what was going on in Laws of Form, especially with chapter 11. But this was something, especially with the in Appendix 1 with the proof of Schaeffer's postulates. It was kind of confusing to me to with just the basic idea of how do you prove modus ponens by using modus ponens, for example, or you know what I mean. So like there is some sort of like if then like modus ponens like structure within language that we use to communicate mathematical thought and write out proofs and demonstrations. But so there was that aspect of laws of form as a whole in which it was written, that confused me a little bit. And I'm wondering if you'd want to, or if anyone wanted to comment on that, or if Leon wanted to comment on that.
It's all circular.
Yeah.
Yeah, it is. But I have put up a course on YouTube going through a close reading of laws of form. So if you haven't watched that, watch it. I go through chapter 11. It took me years to understand chapter 11. Maybe I haven't even understood it yet, but I do my best.
Okay. Well, Leon, thank you. I mean, for me, there's so much in there that I really found very stimulating, and lots of stuff to think about. So thank you very, very much.
Yeah.
Thank you. Thank you all for being here. It was wonderful. And I've been listening.
And thank you all for being here, because we're done week 4. Yeah, I mean, it's like running a marathon. We're still here. We're still in the race, and actually quite a lot of us, which I wasn't expecting. So so that's it. Weekend now, and then we've got Barbara on Monday, which I'm really looking forward to, and some really, really great talks next week as well. So everybody have a really lovely weekend, and I'll see you on Monday.
Mark, before you sign off, can I just ask a purely practical question?
Yes.
About yesterday's talk, which unfortunately I wasn't able to attend because my damned connection crashed.
Yes.
It's still very unstable now. But I saw your posting this morning about something coming from Lindia. Were there 2 talks, or am I confused? What was the talk yesterday,
No.
Lou, in discussion with the other 2 guys, or?
No, so this was Lynn Clare and Chad giving the talk, and it was kind of joint paper with them, and Lou as well was on the.
Oh, I see. So it was the talk. Okay, I understand. Right. Yeah. Okay. That's great.
Brilliant.
Okay. I look forward to downloading that and studying it.
Yeah. Okay. That's good. Okay. Thank you ever so much. This is a real, such an eye-opening and wonderful experience for everybody, I think. But it's great.
Well, thanks again to you for making it possible.
Honestly, I'm not doing very much.
No.
I click a few buttons every now and then, and but it's a privilege. So thank you very much. All right.
Thanks,
I'll see you next week.
All the best. Cheers.
Okay, thank you very much. Bye-bye.
Bye-bye.